Okay, section 6.5, graph square root and cube root functions. Parent functions for square root and cube root functions. So the parent function for this family of square root functions is f of x equals the square root of x. It looks like this. Your domain is x is greater than or equal to 0, and your range is y is greater than or equal to 0. We can't put in any negative numbers and take the square root of them, and we will never get a negative number out of a square root. And the parent function for the family of cube root functions is g of x equals the cube root of x. Looks roughly like that. The domain and range are both all real numbers. So we're going to graph a square root function, and then we're going to compare it to the graph of the square root of x. So we're going to graph negative 2 square root of x. And you can use your calculator to help you with this. So just to have our square root of x function look roughly like that. So then negative 2 times the square root of x is going to come down. I'll do that in a different color. So it'll come down, but it's going to come down a little more than this one came up because we're multiplying it by 2. So our domain, x is still greater than or equal to 0, because we only have positive x values. But for our range, y is less than or equal to 0, because we're on the negative side. And then it is a vertical stretch of the graph of the square root of x, because it came out stretched just farther down, multiplied by 2. And it's a reflection in the x-axis because it's flipped down. So now we're going to do the same thing for a cube root function. We're going to graph one and compare it to the cube root of x. We're going to also state our domain and range. Remember, our cube root of x function is roughly like that. And you can also, on your calculator, you can just graph the cube root of x and 3/2 cube root of x, and you'll see the difference on there. If you don't remember how to get to cube root, it is under Math 4. So then when you do 3/2, you should see that it comes down a little lower here. So it goes through here and comes up a little higher. Because the graph of the cube root of x is a vertical stretch. See that? And our domain and range are all real numbers. Okay, so solving a multi-step problem, biologists have found that the shoulder height, h, in centimeters of a male African elephant can be modeled by h equals 62.5 times the cube root of t plus 75.8, where t is the elephant's age in years. So we're going to use our calculator to graph the model. 62.5 times the cube root of, we're going to use x here. Make sure you close your parenthesis after x or get away from underneath the radical. And then you're going to graph it. And we're going to estimate the age of an elephant whose shoulder height is 200. So we want to know when h is 200. So in order to do this on your calculator, we have y1 equals 62.5 times the cube root of x plus 75.8. We're going to make y2 equal to 200. And then we're going to have to change our viewing window. So next to y equals, there's window. We need to change our y's. We don't, the x we might be okay on. So let's try changing the y values. We're going to make y min equal to 0. Let's make y max equal to, we need to be more than 200. So let's make it 300. And let's make our y scale 50. And then we're going to hit graph. And we're looking for the two things to intersect. We're looking for our cube root function to intersect with the line 200. So I see my intersection on here, so I don't need to adjust anything anymore. I'm going to go to second trace, which is my calc menu, and I'm going to calculate the intersect menu. I'm going to calculate the intersection, so I'm going to select intersect. So it's already on the first curve, so hit enter. It jumps to the second curve, hit enter, and then just go where the point of intersection is. We're close enough, and then hit enter again, and it's going to tell you it's about 7.8 and 200. So that means it's 7.8 years. Approximately equals. Okay, so just like any other transformations, we're going to have transformations on the square root and cube root functions. So to graph y equals a times the square root of x minus h plus k, or y equals a times the cube root of x minus h plus k. First, we're going to sketch our graph of the parent function. But we'll do it with the multiples. So first we're going to sketch the graph of a times the square root of x, or a times the cube root of x. From there, we're going to translate it horizontally h units and vertically k units. So we're going to use that to graph our next functions. And when you translate them, you can then use your calculator just to see if you did it correct. So we have y equals 3 times the square root of x plus 2 minus 4. So the first thing we're going to do is we're going to graph 3 times the square root of x. So when x is 0, we're at 0. When x is 1, square root of 1 is 1, times 3 is 3. When x is 4, always pick numbers you can easily take the square root of. When x is 4, the square root of 4 is 2. 3 times 2 is 6. So 4 is 6. You just want enough points so that you can translate them. So now we're going to shift it h units left or right and k units up or down. So remember, this has to be in the form of x minus h, so it's x minus negative 2. Or you can try to remember it that with the left and right, you always go opposite. Since it's x plus 2, you're going to move everything 2 units to the left. So I'm going to take each of these points and move them 2 units to the left. This one here, which is at 4, it's now going to be 2. Okay, so that's my graph now so far. So all I did was move it left. And now I'm going to go k units, which is negative 4, down. So I'm going to take each of these points now and move them down 4 units. This one here, 1, 2, 3, 4. And 1, 2, 3, 4. And that's my final graph. It ends here. It does not continue on, but it'll continue on in that direction. And then we need to get our domain and range of our final graph. So for our domain, x starts at -2, and then it goes to the right. So x is greater than or equal to -2. And for our range, y is all the way down at -4, and then it goes higher than that. So y is greater than or equal to -4. Okay, so now we're going to graph y equals -5/2 times the cube root of x minus 2 plus 3. So you just want to try to get some values to start with. And we're going to start by graphing y equals -5/2 times the cube root of x. So we know the general shape, but we also have that negative there, which of course makes it a reflection. So at 0, we're at 0. At 1, we're at -2.5. At -1, we're at +2.5. So right now it looks like our graph's aligned, which is why we need more points. So I'm going to pick something else I can take the cube root of, like 8. So at 8, I'm at -5. And then at -8, I'm also going to be at +5. You just want enough points so that you can kind of get your nice curve. Just to get an idea what it looks like. Not the best graph, but... So now we're going to take each of these points and move them all 2 units to the right. So this was at 8, so we're going to go back to 6. This one here, we're going to go 2 units to the right to +1. At 0, we're going to go 2 units to the right to 2. This one here, we're going to go 2 units to the right to 3. And then we have to extend this out to 10. And go 2 units to the right at 10. Now we can redraw our graph. And then we're going to take each of these and move them up 3 units. So here. This one is going to be up 3, 1, 2, 3. This is going to be up 3. This one's going to be up 3. And this one's going to be up 3. Which was... It's going to be up there somewhere. And then we'll just connect it again. And that's roughly what your graph is going to look like. And then our domain and range are just all real numbers. And then you can verify that by putting -5/2 times the cube root of x minus 2 plus 3 on your calculator and just see that it looks roughly like that and you have those points on your graph.